So what we're going to look at now is the graphs of the circular functions, in particular the sine function. And if we have a look at what we've got here, we've got this rule here, y equals sine x. So let's see how we come up with this graph. So what I've got here is the unit circle, okay, and our angle starting here at 0 degrees, and we're just going to, I'm going to press play, and you'll see what's going to happen is this angle is going to increase, and it's going to work its way around the unit circle and see what happens as we graph it. So it's going to be graphing the y value, the y coordinate of this point as it works its way around the unit circle. So you can see it working its way up. Whoop, we'll stop there. So it started at this value, it's gone all the way up around here, and this red line is the plotting of the y value of this point as it works its way around the unit circle. And so you can see what's happened is once it's gotten to pi on 2 radians here, or 90 degrees, it's reached its maximum y value. And so we've got this crest happening here, the very top, the maximum value of the sine function. And then as we go around, okay, it works its way down again until we get to pi radians, or 180 degrees, and it gets down to a y value of 0. And we've already seen how sine is positive in the first and second quadrants. And then when we go here, we're going to go past pi radians, and we're going to get into the negative value. And so what we're going to see is it's going to go work its way down. Okay, it's working its way down, reaching its bottom, and then getting up to 2 pi radians. So it's worked its way around here, a complete circle. Okay, it's gone around the unit circle once, so that's one complete revolution, and we can see what's happened is our graph is plotted like this. It starts at 0, works its way up to 1, goes down to 0, goes down to -1, and comes back up to 0. What's going to happen then is that hopefully you'll see that as we work our way around the unit circle again, it's going to repeat that same thing. Okay, so except it's just not showing it past there, but if it continues on, it would just continue to go. Okay, it would actually continue on past here and keep going all the way along. All right, so that's for sine. And if we do cos, you'll notice that the cosine function, same shape, but it starts when our value is at, or our angle is at 0. When our angle is at 0, our x coordinate is 1, and so that's why so this is for y equals cos theta. Okay, so it's plotting the cosine function because it starts at a value of 1 here, because it's our x coordinate, and so plotted up here, it starts at 1, works its way down until we get to pi on 2 radians, which has an x value of 0. So we're plotting that. That has a value of 0 and then goes down to -1 once we go past here. Okay, so that's our cosine function. It's at -1 there, around to here, goes to 0 again, and then back here it gets to 1. So you notice the shape of the cosine function and the sine function are exactly the same, except they are what's called out of phase with one another. They are the same shape, but translations, horizontal translations of each other. So let's just try and just get a few things from this. There's some important things to remember of the functions for sine and cosine. First of all, you'll notice that it repeats itself. So as we go one complete revolution, and then it starts to repeat itself, that's why it's called a periodic function. Okay, the graph repeats itself every 2 pi units, or every 360 degrees. And so this is what we call the period. Okay, how often does the graph repeat itself? It repeats itself every 2 pi radians. So the period is 2 pi. The amplitude, that's the distance from here to here, or it'll be half the distance between the maximum and the minimum. So the amplitude is 1. Okay, and then the maximum and minimum values of sine x are 1 and -1 respectively. Cosine function, okay, so for the graph of y equals cos x, same shape, only it's shifted across, translated pi on 2 radians to the left. So, and it also has a period of 2 pi radians. So every 2 pi, the graph repeats itself. And again, it has a maximum and minimum value of 1 and -1. And its amplitude will be 1 as well. So that's the graphs of sine x and cos x.